All right, so this is going to be our first screencast for calculus. All right, you should take notes as you go along. You should write down any questions that you have. You should try the examples on your own and make sure you understand them as we go through them, or try them on your own and then check your answers and listen to what I say after, after you do it. Play again and see it. Make sure you come with questions if you have any to the next class. All right, so increments. This section 1 is all about lines, but maybe you haven't heard of increments, or at least called them that before. Increments are just delta x and delta y. All right, so change in x and change in y. In other words, x2 minus x1 and y2 minus y1. So if I'm finding an increment between these 2 points, delta x then will be x2 minus x1, or negative 2, and delta y would be y2 minus y1. That'd be 8. So remember, minus the negative makes a positive. All right, so I want you to try this one over here. You find the increments, pause, and then check your answer with me. All right, did you pause? Don't go on without pausing and checking. All right, so the first one should be 0. Next one should be negative 5. All right, so the way you've probably used increments before is when you're using slope. We have several notations for slope, okay? M is usually what we call slope. We say rise over run, especially when we're graphing. And we use delta y over delta x. We're going to use that a lot in calculus. And so, in other words, the formula is y2 minus y1 over x2 minus x1 when you put the formulas for increments in there. So examples, the slope from 4, negative 3 to 5, since we got delta x to be, let me see if I remember, negative 2, and then delta y we got to be 8. So our slope would be delta y over delta x, and reduce that to negative 4. All right, the slope from 5, 6 to 6, 1, remember our delta x was 0 and our delta y was negative 5. So our slope would be negative 5 over 0. And if you recall, you cannot divide by 0. We call that an undefined slope. All right, so just as a side note, remember undefined slope means it's a vertical line at x equals 5. All right, at x equals 5. We'll talk more about it in the next slide. All right. There are several ways you can write equations of lines. Point slope form is one of them. Y minus y1 equals m times x minus x1. That is one way to write point slope form. Some people put the plus y1 on the other side. I find that confusing myself. That is if you're given the point x1 comma y1 and you are given the slope. Okay, that's when you would use that. A slope-intercept form, y equals mx plus b. Everybody uses that. That's your favorite Algebra 1 and even Algebra 2 form. That's when you're given the slope and you're given the y-intercept. Okay. Now, general form is ax plus by equals c. Some people use standard form. Standard form is a little different. It looks like this. They're really very similar, and I use them almost interchangeably, really. All right, vertical lines, I just want you to remember, have a special equation. Vertical lines, like if I graph this line right here, it's x equals 5, okay? X equals, it looks like x equals some constant. And horizontal lines are similar. So this one would be like y equals 3. It's y equals a constant. All right, we know parallel lines have the same slope. All right, so why is that? By the way, we're going to skip the examples, same here. All right, so parallel lines have the same slope. So parallel lines have the same slope. First of all, we're going to say, all right, two parallel lines cut by a transversal, the x-axis is a transversal, mean that corresponding angles, the ones that I've just marked, they're congruent. That's a geometry fact that we know. So now, and do a little trick here and drop a perpendicular, making two little right triangles. I hope you see the two little right triangles. Now, those two triangles, so far, they have two angles in common. Okay, angle, angle. But I want to drop this right angle just so that it's one away. Okay, one away from the original angle. So now I've got two triangles with angle, side, angle matching. That means they're congruent. So those two triangles are the same. So whatever this length is and this length is, the way I drew it, it has to be the same. Has to be. So I'm going to call it A and B. Now, A equals B. All right, now, I also know that the slope for this guy right here, for this line, M1, the slope for the line 1, is rise over run. It equals A. And I know this slope right here for this line, slope 2, is rise over run. So M2 is B. So A equals B, but A is what M1 was, and B is what M2 is, so M1 equals M2. Voila. Now, you are not expected to reproduce that. However, you are expected to be able to follow it. If you need to stop, pause, go back, rewind to make sure you understand why, that's important. All right, so perpendicular lines. All right, excuse the jump. Perpendicular lines have the opposite reciprocal slope. Okay? Some people like to define that, and maybe it's a better definition, is M1 times M2 equals -1. It's another way to do that. All right, so this is a little convoluted, so bear with me. Okay, again, you don't have to necessarily reproduce this, but it's nice that you understand where it comes from. All right, so we've got two perpendicular lines that I drew. We're going to call this theta 1. We're actually going to call this guy out here as theta 2. All right, and I'm going to drop a perpendicular and altitude right there. Now, this left hand, so there are three right triangles. There's this guy right here on the left, there's the one on the right, and then there's the big one that makes with the x-axis. All right, if that's theta 1 and this is 90 degrees, then this guy, this dot right here, and theta 1 have to be 90 degrees together. That means since this is a 90-degree angle, this guy right here has to be theta 1 because those two together make 90 degrees. All right, so this triangle here and this triangle here are similar by angle, 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 angle even, if you will. So you erase those dots to get them out of the way. Now, I'm going to call this guy A and this guy H. I know that right here that in this triangle, it helps us find the slope for L1. The slope for L1, so slope 1, is rise over run. H over whatever the heck that is. But that doesn't help us. H over whatever the heck this is really tangent, right? Opposite over adjacent. So really, the slope is tangent of theta 1. All right. But look at this triangle right here, and tangent of theta 1 is equal to opposite over adjacent, A over H. All right, so really, slope 1 is A over H. I'm going to erase some of that extra stuff, so pause if you need to, and rewind if you need to rethink that. All right, I'm having trouble here figuring out why I cannot erase. So, we're just going to deal with it. I'm sorry, bear with me again. Now, what is the slope for L2? Well, it's the tangent of this angle right here, A over H. Excuse me, H over A is the slope there. But this angle right here is the opposite way. If we were thinking unit circle, okay? It's in this quadrant over here. It's in the second quadrant. Tangent is negative in the second quadrant. It's a negative H over A. Now notice, my slope 1 is a over h, and my slope 2 is negative h over a, opposite reciprocals. And there you have it, that's why. All right, so if we do some examples where you need to write the equation of the line through 2, 3 with slope negative 2, 3. I'm on the littlest one. All right, so we're going to use y minus y1 equals m times x minus x1 because it's a point and a slope, so use point slope form. Y minus y1 equals m times x minus x1. Now, I'm perfectly acceptable. I think it's perfectly acceptable to leave it just like this. AP thinks it's perfectly acceptable to leave it just like this on open answers. However, you might on a multiple choice see it rearranged. So you might need to distribute and change it to y equals mx plus b, which I'm sure you can do. But you do not have to. All right, so write the equation of a line perpendicular to the above one. It's going through this point. Okay, so got a point. If it's perpendicular to the above one, remember the slope has to be the opposite reciprocal of that slope. So since its slope was negative 3 over 2, this guy has to have a slope of positive 2 over 3. So point slope form again, y minus y1 equals m times x minus x1. Now, it's minus a negative, so I'm going to change it to a plus, all right? If you really can't stand this and you need to distribute your 2/3 and add the 4 to both sides, go for it. Now, write the equation of the line through these 2 points. Well, we can find our slope using delta y over delta x. Okay, delta y is 3 minus negative 2 over 4 minus negative 1. So I get 5 over 5. That's a positive 1. All right? So that's my slope. And choose one point. I'm choosing this one. You might choose the other one. Actually, the other one might be easier because it's positive. So y minus y1 equals m times x minus x1. So minus minus makes a plus. That's why those are plus. Now this one, I see it's a 1, so I'm going to, you don't have to distribute it. I'm going to move that plus 1 over. You can leave it like that. It's not wrong, but it's driving me a little bit insane, so I'm going to subtract the 1 from both sides, and I get y equals x plus 1, as my equation. All right, so now if I'm writing the line parallel to that, well, parallel lines have to have the same slope. So since our slope was 1, this guy has to also have a slope of 1. Parallel has the same slope. And it's got to go through that point. Okay, so y minus y1 equals m x minus x1. And, okay, y minus 0 is y. So I'm going to simplify that. And I can distribute 1 without writing the 1 in there. So there you go. That's your equation. All right, now find the slope and y-intercept from this guy in general form. I personally would do that by moving it to y equals mx plus b form. So first thing I'm going to do, subtract 8x from both sides. Next thing, divide by 5. You can change it to a fraction or a decimal if you really want, but it seems silly when you could just leave it like that. All right, so we've got this line with this equation right here, 3x minus 4. Write the equation for the line through this point. It is parallel to that line and perpendicular. Well, okay, parallel has to have the same slope as this original line. Since this slope is 3, this has to be a slope of 3. We know it goes through this point right here, so point slope form. Y minus y1 equals m x minus x1. Again, minus negative 1 makes a plus 1. So perpendicular, instead of having a slope of 3, now it has to have the opposite reciprocal slope. All right? So put it in point slope form. Okay, we found the slope. We still need to put it in an equation. Y minus 2, y minus y1 equals slope times x minus x1. And there you have it. No need to change it to y equals mx plus b unless they tell you to. All right, find the equation of the line given the following table. Those fractions look nasty, and I would quite frankly just go straight for a regression line. But if you want to go old school, now, I see right here, I can do some easy math in my head. I am doing my delta y equals positive 1 because 2 minus 1. And this one looks like negative 13 minus negative 4
I'm going to get negative 9 over 3 for my delta x, or just negative 3. Okay, so I kind of cheated and did it in my table. I show my freshmen how to do this, and they love it. Okay, so that's my slope. All right, so that's my slope. I'm going to choose this point just because it's easier to circle since I wrote all over the other two, but you could choose any of the 3 points. Y minus y1 equals m times x minus x1. Voila, done. All right, now this last problem has to do with regression. Use the data in the table to build a linear model for the growth of world population. That should say world population. All right, use the model to predict the world population in the year 2010 and compare this prediction with the statistical abstract prediction of almost 7 billion, 6.8 million. All right, so if you have forgotten how to do linear regression, I'm going to add a webinar, I guess, tutorial on how to do this in your calculator again. Basically, you have to go to stat, edit, enter them in L1, L2, and do a regression. Stat, calculate regression equation. Now, I got my regression equation when I did that. If you need help, remember, go to the other video on how to do that in your equation. My regression equation turned out to be y equals 79.957x minus 15,000, I said that wrong, 153,848.716. All right, now, I'm using 3 decimal places because that's what AP asks. So for our class, we're always going to use 3 decimal places. AP says you can round correctly, or you can truncate, means you can just cut off the end. You don't have to worry about rounding necessarily. All right, now remember this is in millions. So this is our regression equation. Years are X, population is Y. So if I want to predict the world population in 2010, that's an X because years are X. So put in 2010. Y equals 79.957 times 2010 minus 153,848.716. And if you do that, you should get about 6,865 million people. All right, now, so how close is that? It says compare it. So compare it to the statistical abstract. Obviously, it's a little bit higher than what the statistical abstract predicted, about by 50 million. So it is a little bit higher.